Hello and welcome to another Science 9 crash course. In this episode, we're going to talk a little bit about chemical changes and a lot about the atom. The first topic that we're going to discuss in this episode is something called the law of conservation of mass. This law states that in a chemical change, the total mass of the new substances is always the same as the total mass of the starting substances. What this really means is that during a chemical change, matter can neither be created or destroyed. So if you were to burn a matchstick and measure the mass of the matchstick as well as the oxygen required to burn it, that would equal the mass of the leftover matchstick as well as the CO2 and the water vapor given off. Another law that we need to discuss is the law of definite composition. This law states that compounds are pure substances that contain two or more elements combined together in fixed proportions. For example, in this water molecule and every other water molecule, there will always be one oxygen for every two hydrogens, and carbon dioxide molecules will have one carbon for every two oxygens. Chemists were able to understand this law by using a simple little experiment called electrolysis. Electrolysis is the process of decomposing a chemical compound by passing an electric current through it. And as you can see here in the decomposition of water, it produced twice as much hydrogen as it did oxygen. So therefore, it must have twice as many hydrogen atoms as there are oxygen atoms in the molecule. Since we're talking about atoms, let's now discuss how scientists were able to discover the atom and also the structure of it. The first scientist to come up with a theory about the atom was John Dalton. He developed an atomic theory that had 5 main points. The first point in his theory states that all matter is made up of small particles called atoms. He also stated that atoms cannot be created or destroyed or divided into smaller particles. He was kinda wrong on that one. He also stated that all atoms of the same element are identical in mass and size. And that one's really not true either. Sorry Dalton, you're only 1 for 3 so far. His fourth point states that atoms of one element are different in mass and size from the atoms of other elements. And his last point states that compounds are created when atoms of different elements link together in definite proportions. Dalton's model of the atom is called the billiard ball model because he thought that all atoms were just round spheres. Sadly, Dalton was wrong in many aspects of his theory of the atom. But of course, later on, scientists came along and revised the model based on different experiments. The next scientist's name was J.J. Thomson. He revised the model of the atom and called it the plum pudding model or the chocolate chip cookie model. He thought that the sphere of the atom was positively charged and that there were negatively charged particles attached to the surface of it. J.J. Thomson was given credit for discovering the first subatomic particle, the electron. The electron is a negatively charged particle inside of the atom. Sadly, again, J.J. Thomson's model of the atom was of course wrong. The next scientist to come along and do an experiment and change the model was Ernest Rutherford. Through his experiments, he discovered that the positive part of the atom is actually quite small in the center, and that orbiting around it are negatively charged electrons. He is also given credit for discovering the positively charged subatomic particle, the proton. The proton is of course a positively charged particle, and it resides in the center of the atom called the nucleus. The name given to Ernest Rutherford's model is called the planetary model because it represents the planets orbiting around a sun. But of course, Rutherford's model was a little wrong. So another scientist came along by the name of James Chadwick and corrected one of the flaws in Rutherford's model. In Rutherford's model, he could not explain why helium was 4 times as heavy as hydrogen even though it only had 1 extra proton. Chadwick predicted that there must be some other subatomic particle that is heavy as a proton but has no electrical charge, and thus gave rise to the neutron, which is a neutrally charged particle found inside the nucleus. Other scientists came along and changed and modified Rutherford's model. For example, Niels Bohr believed that electrons could reside in fixed energy levels. Today in chemistry, the accepted model of the atom is called the electron cloud model. This model also believes that there are protons and neutrons inside the nucleus, but that negatively charged particles or electrons are more likely to be near the middle of the atom. This is called the electron cloud. Well, I guess that's all, and hopefully you've learned a lot more about the atom. Thanks for listening.